Good morning, teachers and my fellow classmates. I'm Jia Tong, the leader.
I'm Afan, the timekeeper.
I'm Inshan, the facilitator.
And I'm Leia, the recorder.
And I'm Wenho, the ICT champ.
And we are from Group 1. Today, we are presenting to everyone about Task 2. For Task 2, we have fast walker and slow walker going for a walk at Jurong Lake Gardens. When the slow walker indicates an intention to turn around and return to starting point, the fast walker then carry on for a time at a faster pace before also returning, especially if the opportunity to travel further and faster is appreciated. The fast walker will want to go as far as possible. When the slow walker starts the return trip, we need to find at how much extra time should the faster walker carry on before also turning for home, so that both will arrive at the starting point at the same time. This is the map of Jurong Lake Garden. This is the assumption in this strategy. We assume that the distance from the starting point and ending point to the turning point is 3 km. The faster walker speed is 5 km per hour and the slower walker speed is 4 km per hour. Represent fast walker as F, slow walker as S. Let starting point and ending point for both F and S be A. Turning point for S is represented as B. Since F is faster, to let both of them to reach the ending point A at the same time, we let F walk an extra distance. The turning point for F is represented as C. What information is required to accomplish the task? Total distance of Jurong Lake Garden, slow walker speed and fast walker speed.
Okay, hello guys. My name is Afan. Okay, so for today, right, we have come up with two solutions. One of them are solution one. So the faster walker will walk a longer distance. So we assume that the slow walker will walk at 4 km per hour, and the fast walker will walk at 4 km. Then the fast walker will walk at 5 km per hour. The distance the fast walker need to walk is 7.5 km, and the distance for slow walker need to walk 6 km. We will start everything at 8 a.m. Okay, to find the distance, we will need to times the speed and the time. So the first solution, we will start at the same time, but later the second solution we will start at a different time. So the time the fast walker to walk from point A to point B, so we need to divide it. So 3 km divided by 5 km per hour. So we convert it into minutes, we will get 36 minutes. And then for time for slow walker to walk to point A to point B, we will need to 3 km divided by 4 km per hour. Then we convert it into minutes, then we get 45 minutes. So to present it mathematically, we have done a diagram to show you all. So from point A to point B is where the slow walker will walk, which is 3 km, and then point A to C is where the fast walker will walk. So since we want the fast walker to walk more, we go for point A to point C and point C to A back. So the fast walker will walk 9 minutes extra, and then the slow walker will walk point A to point B and then back to point A. So for the fast walker we name it F, and for the slow walker we name it S. Okay, so in order for S to return first, F need to wait for S for 9 minutes. So basically we need like so F decided to walk an extra of 0.75 kilometer. So 9 divided by 60 uh hours times 5 km, and from B to C, which took 9 minutes. Thus, in order to find F and thus in order for F and S to reach point A together, F will need extra 18 minutes because it takes um two trips, which is from A to C, then C to A back. And because it took 9 minutes itself towards him, and another 9 minutes back to C to B. Okay, thank you.
So for example, at 8 a.m., both F and S start walking at the same time from point A. And at 8:36 a.m., F will reach from point A to point B. At 8:45 a.m., S will reach from point A to point B, and F will reach from point B to point C, which is the extra distance he walked. At 9:30 a.m., both will reach to the ending point together at the same time. Moving on to solution 2, the assumption we make is that slower walker will start earlier than the faster walker. For both of the walker, their speed will remain the same, and they will both walk a distance of 3 kilometers. So this is the timeline for the solution 2. So how do you know that the slower walker will need to start 18 minutes earlier than a faster walker so that they will return to the endpoint at the same time? The total time taken for the slow walker is 72 minutes, and for the faster walker it's 90. Okay, sorry, the slide is wrong. So the faster walker will walk 72 minutes and the slower walker will walk 90 minutes. So the extra time the faster walker need is the highest common factor between 72 and 90. So the highest common factor is 18, so the slower walker will start 18 minutes earlier than a faster walker.
So what are the constraints? It is hard to keep the same walking pace as it may contain human free error, and it is hard to estimate the speed as the walker's pace may not be consistent throughout the entire walk. For solution 1, the people need to measure the extra distance accurately before going for the walk. Looking back, in solution 1, the extra distance depends on the speed of the walker, so there is a need to calculate it to match the extra distance. While in solution 2, we will need to use guess and check, but if we found both timing, we could find common factor. In solution 2, S start walking at 8 o'clock and F start walking at 8:18. At 8:45, S reach point B, and at 8:54, F will reach point B. At 9:30, both S and F will return at the same time. For our preferred solution, we choose solution 1 because it is easier to understand and more accurate. We also gave the fast walker the opportunity to go as far as possible. Since for solution 1, we add an extra distance for the fast walker, this ensures that both fast and slow walker will reach ending points together and the fast walker does not have to wait for the slower walker, which suits the question better. However, for solution 2, we use the method of finding the highest common factor, and it works backwards to find whether F and S will return together. Using the highest factor, if the total time taken for the entire journey changes, therefore we chose solution 1 instead of 2 to ensure not to make careless mistake, increasing the accuracy and reliability of the solution.
So our answer and solutions are based on the total distance both walkers walk because their speed is constant throughout the whole journey. So we need to try different distance of the place but with the same speed of both walkers so that we will get a various number of timing because the distance might change. We can use both solution but there must be a difference in speed of the walkers. So how can our modeling strategy can be extended to related problems? So using solution 2, for using solution 2, we can find for example, Bukit Batok Natural Park. The distance is 2 km and the speed for fast walker is 5 km per hour and slow walker for 4 km per hour. So using the formula, this formula distance divided by speed, as timing for him to walk 4 km will be 4 divided by 5 equals to 0.8 hours, which is 48 minutes. So F timing for him to walk for 4 km will be equals to 4 divided by 4 equals to 1 hour, which is equals to 60 minutes. So S timing minus F timing, it will be equals to 60 minutes minus 48 minutes, which is equals to 12 minutes. So the extra time will be 12 minutes. So these are the solutions. So these are solutions that we found. And then the group reflection is that we think that this math activities is very challenging, but we managed to find two ways and work on the solution. Even though it is very hard to understand the question, but we overcome the challenge. It enhanced our bond as a group who do not know each other well enough. Although it is hard to estimate the distance for the whole walking journey, we did research to ensure the accuracy and reliability of the solution. We get to know each other better through this project, and we enjoy this process, and we are very happy. So thank you for listening to our presentation.